Hi everybody, this is Luke and welcome to the first episode of ThursDev on the Level 0 NPCs channel. Today's episode is going to be a little bit out of the box in comparison to our usual Let's Play stuff. We're starting a new series as of today where we're going to be doing videos talking about game development, including some tricks of the trade, theory, and a few practical examples of the techniques that we use to make games to get you familiar with the tools that you're going to need if you ever want to start doing it yourself. These videos are going to be aimed towards beginners, to intermediate people, to people who have been doing it as a sort of a hobby, and so on and so forth. But for each individual episode, all three of the NPCs, that's Matt, John, and me, will be focusing on talking about our individual disciplines and specialties in focused solo episodes. Matt is an artist who works both in 2D and 3D. He works in Sculptress, Topo Gun, Mudbox, Substance Painter, and Photoshop, and he can teach you more than a little bit about art for video games, and most likely will. And John is a writer and a producer and also does sound design. His episodes will cover things like sound editing, Foley, as well as writing and the tools of the trade used by game producers. As a designer, I'll be talking about design theory, system and mechanic design, game engines, and scripting in Unreal 4, which is my personal engine of choice. Now, to kick off the series, I am going to do a little bit of a talk about game engines, in particular Unreal Engine 4, which is going to be the centerpiece of the work that we're going to be doing in this series, and by extension, the Arc Dev Kit, which we'll also move into as a base for some practical experiments after we've had a chance to look at the engine. We're going to begin by familiarizing ourselves with the Unreal Engine, and then we'll jump into some Arc modding. Now, you're probably wondering why jump into modding first? Why not start developing our own game right from the get-go? And you absolutely could jump right into starting to develop your own project in Unreal 4, but modding allows you to jump into something with a lot of content that's already ready to go. Getting started from the ground up is a big task. There are a lot of things that you need to do right up at the front, and so instead of getting the boring stuff started, we're going to piggyback on another game to get ourselves acquainted with some basic small-scale development and individual mechanic design first. But I'm kind of getting ahead of myself. If you want to make an apple pie from scratch, you first must create the universe, as they say. In this case, our universe is called a game engine. Now, a lot of you watching this channel will probably already be familiar with the term game engine, but some of you might not exactly understand just what an engine is or what it's sort of where it extends to in the development of a video game. Put simply, an engine for a game is a computer program that includes code to render graphics, called a rendering engine, and also includes things like a physics engine and collision detection, some sound handling, animation, basic AI, network connectivity, and pretty much all of the other tools that you need to make a game without being a game itself. Some engines are more powerful than others. Some are designed specifically for certain kinds of games and sort of sacrifice functionality for others, such as the popular RPG Maker engine by Enterbrain, which is designed to make games based off of old-fashioned JRPGs. Or one of my favorites, the Adventure Game Studio, which is designed to allow you to create point-and-click adventure games, and incidentally is where I got my start in game development quite a few years ago. Now, when planning your game, because of this, one of the most important decisions that you can make right off the beginning is to decide what engine to use. Some development studios have their own in-house engines, and some developers create their entire game without the help of any engines at all. A vast majority, though, are sort of gravitating towards free commercial engines, and the two big juggernauts of the industry right now are Unreal and Unity. You'll probably also have heard names like Gamebryo, CryEngine, and some particular savvy customers will probably recognize Stingray or Anarchy. And there really are a lot out there, but the two big U's are dominating the market because they give away the farm, as it were, by offering their engines free for evaluation and commercial projects, as long as you're willing to pay royalties after making a certain amount of profit. They're awesome tools, though, and Unreal 4 is my weapon of choice. So I'd like today to take a brief look, just an overview of the Unreal Engine. Now, as a little bit of background, Unreal Engine is created by Epic Games, the company behind Unreal and Unreal Tournament, which is the engine's namesake, of course, as well as other titles like Gears of War, Bulletstorm, as well as some games that old farts like me will get nostalgic over, like Jill of the Jungle, Jazz Jackrabbit, and Epic Pinball, which was making the rounds in the shareware space many, many years ago. But to get started with Unreal 4, you're going to need the Epic Launcher, which can be downloaded from the Unreal Engine webpage, which looks like this. And I will link this also in the video description. From here, you are going to need to just sign up for a free account. I'm already logged into mine. And after you're signed up, go ahead and click Get Unreal, and you'll be good to go. I've already got mine installed, so let's just jump right into that. It'll ask you for your login, and once it's done, this is what you'll see. Once you're inside the launcher, you're going to find a number of tabs. There's Unreal Engine, Fortnite, Shadow Complex, which, by the way, I fully endorse and think that you should definitely check out. It's a fantastic Metroidvania game, and now it's free. And Ark, which we're doing a Let's Play series of, and we're going to go into very much detail later because the Ark dev kit is a sort of subversion of Unreal Engine, and we're going to be using this in some practical examples later. But we'll get into that when we get into that. Let's go back to Unreal Engine here and get ready to download the engine itself. From here, you've got a launch button. Go over to your library, and you'll see this engine versions row here. You can add a version and install the latest. Ahead and install version 4.1.2 or whatever is newest as of your viewing. Right now, 4.1.2 is the latest as of the airing of this video. Now, it's going to take a while to install, but once it's ready, you can launch the engine, or editor, as it's often called, from right here. Now, it can take a little while, but eventually it'll pop up and ask you if you want to create a new project. And if you want to create a new project, what kind of a new project do you want? Blueprint or C++? And they have a lot of little templates in here that you can use to kind of get a head start. So I'm going to open up my own project for this particular episode. Now, once you've got the editor open, it's going to look something like this. I've moved and resized some of the individual panels, but general content is going to be mostly the same. The windows populate contextually based on what's open on the screen, so when you have a specific actor or object open, the layout and behavior of your windows will alter to show you the information that you need. Right now we're looking at the map window, which is sort of your main screen. It shows the level that you're currently working on and editing, and from here you can also create a map, alter the script for events that happen in an individual map through this level blueprint here, which we'll look at another time. And also from this location you have access to the content browser, which is this window down here, and it is the library of all of the content within your game. I've got some very basic things already set up in this particular project, which we'll go over in more detail in the next video, but for now let's just open up the camera actor, which is actually our player character, and see what exists within. So here we have the heart and soul of Unreal 4, the visual scripting tool, which is referred to as Blueprint. I'd just like to say that if you're someone like me who has a passing grasp of scripting and generally knows how computers think, but can't program their way out of a paper bag, Blueprint is a boon when you need to rapidly prototype gameplay mechanics or just do game scripting when you don't really have a head for the text-based stuff. Instead of needing to script in a text-based scripting language like most engines do, Unreal has moved to this system, which handles basically everything as nodes and wires, as you can see here. Back in the day of UDK, which is shorthand for Unreal Development Kit, which is the common name for Unreal Engine 3, there was a similar system called Kismet, but Epic has doubled down on the visual scripting system and turned the whole engine and most of its functionality into event-based node scripting like this. Now, as a non-programmer, I can't really speak to how much more or less intuitive it feels for people with a background in C++ and various scripting languages, but for me, it's like I suddenly have control over my video game universe in a way that I couldn't get before. Now, I should mention as a disclaimer, though, that there are still things that are going to be much more elegantly accomplishable through coding in C++, and thankfully UE4 does have full integration with Visual Studio to that end, but you are fully capable, should you want to, of creating a functioning game using only Blueprint. I've done it, and if I can, believe me, you can. So what exactly can Blueprint do? How does it do it? And what do all of these nodes and wires mean? Well, I should preface by saying that if you're completely script illiterate, you're going to have a bad time. You're going to struggle at first because individual nodes still work like the sort of functions that you would type out in a block of script. You're going to want to learn a number of terms as you go, but over the course of my UE4 episodes in ThursDev, hopefully you'll start to get a feel for some of the terms that you wish you knew, and some of the more difficult to grasp concepts like interfaces, casting, structs, arrays, and so on and so forth. You're also going to need to learn things like what a vector is, and what a float is, and how is it different from an integer, and just general terminology like that. And you can't really be intimidated by having to digest all of the above here. Now, you might notice that I'm kind of meticulous with my blueprint, so there's a lot of comments in there, and the nodes are aligned sort of vertically and horizontally typically. It's not always perfect, but there's a snap to grid type thing here. So, but anyway, I plan on keeping things looking nice, if for no other reason than to make it easy to digest what I'm doing at any given time. Now, what I have in this very simple camera blueprint is the first steps in creating a top-down game, like a real-time strategy game, which is why I have it labeled as RTS camera. The function labeled mouse wheel zoom up here is, exactly that. It is a function that triggers when the mouse wheel is scrolled up or down, and a similar function, when it's going up, that changes the length of what's called a spring arm, essentially a boom or an extendable virtual pole that holds my camera in place over the actual actor. Let's take a quick look at what that actually looks like before the event, before we see what the event is actually doing. So this is our viewport. Doesn't look like a whole lot because I haven't shown a whole lot. But if you look over here at the components window, which basically gives you an overview of all of the individual parts, you'll see that we have a thing listed here called a spring arm. And if you look up above, there is a camera attached. And the camera is your viewport, obviously, into the game universe, into the game world, right? So, most basic objects in the game will basically just be a mesh, which is developer talk for a model, and a collision capsule, which is something that basically creates physics events when something bumps into it, that sort of thing. So let's take a look at the event graph. The function of the spring arm is basically just to allow us to zoom by changing its length with the mouse wheel. As you can see here, we have a reference to our spring arm look a little bit closer. There we go. And one of its variables, which is arm length. You can find that variable over here if you're looking for that. But also, if you are sort of in a hurry and you don't want to look very closely, then you can just start typing target arm length, and boom, there it is. So we get the target arm length, which is just a float, which is basically a number that can have decimal points as opposed to an integer, which is always a whole number. And then we add to the arm length or subtract using little math nodes right here by increments, in this case of 150. Then we add that number to the arm length and set the variable, which will cause the arm's length to change after it's finished running this function, and therefore for the camera to move. Simple. It's seriously just basically 3 things, and suddenly you have zooming functionality. Our math nodes say how much to add and subtract, and in this case the compare float that we have up here basically just sets a limit to the maximum and minimum lengths so that we can't zoom forever forward or backward. You could also use a clamp node like I've done down below, which just says this float should never be higher or lower than the specified numbers, as you see here. There are usually a lot of solutions to any given problem, and you can bet that there are people out there who are going to not only have different methods than I do, but come up with cleaner and more efficient methods to accomplish what they want to do. But that's the beauty of experimentation. By doing, you get better. This function is just setting a variable. Virtually anything you want to accomplish is doable through Blueprint. Complex sequence of actions, complete AI logic, playing music, reacting to UI, you name it. Some tasks are easier or harder than others, and honestly some are better served doing through C++, but starting to work out how to do it is the job of a team of a designer and programmer. And hopefully, as a designer, or just as somebody who is dabbling in game development, you should be able to get some useful functionality out of playing around with Blueprint. And we're going to be doing a lot of playing around with Blueprint in the days to come. So next time, we're going to get an actor into the game and we're going to start telling him what to do. But for now, I think there's already a lot to digest, so I'm going to say thank you very much for watching, and I'll see you next time. Take care.